All right, I'm given this function, and this is Wiley plus 4.3 homework, and says for some positive constant C, a patient's temperature change T due to a dose D of a drug is given by this particular function. What I want to do, I don't have all the questions here, but part A wants to know what dosage maximizes, that tells me right away I'm going to find a critical point, but what dosage maximizes the temperature change? So I want to find the change in temperature over the change in the dosage for this particular function. So C over 7 minus D over 8 times D to the 7th power. Well, what I probably would do is multiply. I would distribute this first, so you don't have to do a product rule. So I would get CD to the 7th over 7 minus D to the 8 over 8. And this is what you're taking the derivative of. So the derivative then of CD to the 7th over 7 minus D to the 8th over 8. The C is just a constant, so that's going to stay out front, but I'm going to bring the 7 down, and it's going to cancel with that 7 on the bottom. So I'm only going to end up with CD to the 6, because I have to subtract 1 from my exponent. Same thing's going to happen here. I'm going to bring the 8 down, and that's going to cancel with that 8. So I'm going to have D to the 7th power. How do we find critical points? We set the derivative equal to 0, and we solve this for D. So CD to the 6 minus D to the 7th. I could probably factor out a D to the 6, and that leaves me this. Well, certainly the dosage equaling 0 doesn't make any sense, so this is the only piece I'm interested in, setting equal to 0. And solving for D, I would see that when the dose is this positive constant, so this is the answer, that the max dosage would be at D equals C. The second part of this question asks me to find the sensitivity of the body to the drug. Is I want to see when the dosage maximizes sensitivity. So how I would do that is I would take the second derivative, and remembering this is our first derivative, so I'm going to have to get some room here, and so that's my first derivative. I'm going to take the second derivative, that's what this means, of CD to the 6 minus D to the 7th. This would be 6CD to the 5th minus 7D to the 6th. This is my second derivative that I'm setting equal to 0. Once again, I probably would factor out a D to the 5th, so that leaves me 6C minus 7D. This is the piece that I want to set equal to 0, 6C minus 7D, and that's actually what I'm solving for D. So 7D equals 6C, or D equals 6C over 7. So when D equals 6C over 7, that will be the dosage that maximizes sensitivity. All right. So look at this one. Now I can already see that this is going to be a product rule because I have e to the negative x as one function and sine of x as another function. The first part wants me to find the first and second derivative. So the first derivative, take the derivative of the first term. Well, the derivative of e to the negative x is e to the negative x times the derivative of negative x, which is just negative 1. Leave sine alone, plus leave e to the negative x alone times the derivative of sine which is cosine. Second derivative, so that's it for that one. Second derivative, I'm going to end up, guess what, with a product rule and a product rule. So I take the derivative of negative e to the negative x. As always, I leave the e to the negative x alone. The derivative of negative x is negative 1, and this negative that's already here makes it positive. I leave sine x alone. Minus, I leave minus e to the negative x alone. The derivative of sine is cosine. So that was just this product rule. Then I'm going to do this product rule now. So I take the derivative of e to the negative x, which is going to be minus e to the negative x. I leave the cosine alone. I leave the e to the negative x alone. I take the derivative of cosine, which is minus sine. That's why I threw some space. And if you notice, this piece and this piece are the same but opposites. One's positive, one's negative, so it cancels. These are the same, so I can combine them. There's two of them as negative e to the negative x, cosine of x. So that would be my second derivative. All right, now this problem has a lot more parts. I'm just not showing them on here. So then the next thing it tells me to do is find the critical points. Well, I know I find the critical points by setting the first derivative equal to 0. So going way back up here, I see that my first derivative is negative e to the negative x sine x plus e to the negative x cosine x. I could actually, and I want to set this equal to 0, I could actually divide every single piece by e to the negative x. E to the negative x. In other words, I'm factoring that out and it goes away. I'm left, don't lose that minus sign, with minus sine of x plus cosine x equals 0. Or this is the same thing as saying where cosine and sine are equal. If you go way, 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 way back up here, it actually gives you the interval, because you might say, well, that's a lot of places, but from 0 to 2 pi, the only place cosine and sine are equal would be at x equals pi over 4 and x equals 5 pi over 4. So those would be my critical points. Now I'm going to find inflection points, so I'm going to set this second derivative equal to 0. So inflection points are found by setting the second derivative equals 0. My second derivative was negative 2e to the negative x cosine x equals 0. I could divide out negative 2e to the negative x, negative 2e to the negative x, and of course this just gives me where does the cosine equal 0, again on the interval between 0 and 2 pi, and this occurs at x equals pi over 2 and at 3 pi over 2. All right, the last part says to evaluate the endpoints, 0 and 2 pi, and the critical points, pi over 4 and 5 pi over 4, to be able to find the global max and min. And you're putting this back in the original function. Well, I know sine of 0 is 0, so that's 0. I know sine of 2 pi is 0, so this one's 0. if I plug in here, so I have negative pi over 4, sine of pi over 4, and then this last one, 5 pi over 4 and sine of 5 pi over 4. I actually didn't write the answers down, but if you put this in your calculator, you are going to see this is going to be the larger value, and this is going to be the smaller value. So plug that in your calculator, you'll get two numbers. Remember, the global max is the largest value, and the global min is the smallest value. Alright, if I want to, this is a good example of finding global max and mins. So I have this function f, let's get a color you can actually see. So f of x equals x plus, instead of 1 over x, I'm going to write that like this because it makes it a lot easier to take the derivative. So how do you find a global max or a min? You find the critical points by taking the first derivative, so that'll be 1 minus x to the negative 2, and you set this equal to 0. I'm going to go ahead and move that to the denominator. So if I add 1 over x squared to both sides, I get this. If I multiply both sides by x squared, I get 1 equals x squared. When I square root both sides, I get plus and minus 1, but it said for x greater than 0. So I ignore the negative 1. I want to know if this is a max or a min. I'm going to do this by taking the second derivative. So I'm looking right here. The derivative of 1 is 0 minus the derivative of x to the negative 2. Well, when I bring the negative 2 down, that's going to be a negative and a negative. So negative 2x subtract 1 to the negative 3 power. And so this is going to equal 2 over x cubed. I plug in my critical point, and I can certainly see that this is positive. So that means it's a global min. And, I was like, I know there's another part. And so I find my y value by plugging this back into the original function, which was x plus 1 over x. So that'll be 1 plus 1 over 1. And that's where you get the actual value. So this one actually has no, and it says to enter none, no global max. Okay, the last one, this unfortunately might be kind of hard to read, but basically I have this function, y equals ax e to the negative bx, and I want to first find the critical point and then see if it's a max or a min. Well, if you remember, these are kind of nice because in this case, the max is 1 over whatever that number b is. Well, it's just b. So that's simply my answer, 1 over b. And then what I do with this is I plug it back in. So 1 over b is my x, my critical point, and that's my max for this type of a function. I take and I plug this back into my original equation. So in other words, I'm kind of doing this. Let me rewrite it like this. F of x, and this is my original function. I'm finding f of 1 over b. So where I see an x, I put 1 over b. Where I see an x, I put 1 over b. And that simply gives me a over b e to the, to the negative 1 power, which is my max.